Okay, in this video I'd like to do a couple of example problems. The first two problems on this page, in fact, and the first one says, explain in the words the purpose of the 4B, 5B encoder. And what we see here is the 4B, 5B encoding scheme in this table taken from Wikipedia. And the encoding scheme takes 4 bits as input, and these columns here, the data bits, are the input bits. It takes 4 bits as input and outputs 5 bits as output. And so every time we receive 4 bits, every time the input receives 4 bits, it instead outputs 5 bits. So if it receives 4 zeros, it outputs 4 ones and a 0. If it receives 3 zeros and a 1, it outputs 0, 1, 0, 0, 1, and so on. And so there are 16 possible inputs, 2 to the 4th. There are 32 possible outputs, 2 to the 5th, but we're only using 16 of them here to encode data. And the idea is, well, number one, you can use this code to help detect errors, because only half of the possible output codes are used. If you get an output code that does not correspond to valid input data, then you know you might have an error in your reception of the data. The other thing the 4B, 5B encoding does is it limits the number of zeros that can occur in a row in the output. So for example, in the 5-bit output, if we look at the last bits, we see that at most 2 zeros in a row occur in the last 2 bits of the output. They occur for an input of 0010 and 1110. And what this means, and then if we look at the beginning of the next code, we see that there is at most 1 0 at the beginning of any of the other codes. And that means that we have at most 3 zeros in a row in the output of the 4B, 5B encoder. At most 2 at the end of one output symbol, and then at most 1 at the beginning of the next output symbol. So 3 zeros in a row is the maximum you're going to get here, and that can help with timing recovery at the receiver, where we don't want to have long strings of zeros. So there's 2 reasons why we use it, and those are them. Part 2 says find the output of the encoder when the input is given as such. And what I did was I've already copied that input down. 0001, 010, 101, 101, 011, 001, 110, 110. I think I've copied it correctly. Basically what we're going to do here is we're going to take this input and divide it up into groups of 4 bits. And then on each of these groups of 4 bits, I'm going to look it up in the table up here. So for example, I take the 0010 and find that it corresponds to an output bit sequence of 10100. So I'm basically just going to fill in the bits, 5 bits under each of these segments of 4 bits. Just for my own way of talking about it, I say this is, I'll call this a 1010, and the 1010 looks like it's here, and it gives me a 110 on the output. 10, 110. Obviously it's not 10 and 110, but it's a nice mnemonic to help you get through this. 1101 is gives me a 110 and an 11. The next one, 0110, gives me a 0, 3 ones and 0 here. 0, 3 ones gives me 0, 4 ones. 0110 again gives 0, 3 ones and a 0. And 1101 gives me 11011, and all ones gives me 11101. Okay, so that's how you can do it, and you can see now that we've got 1, 2, 3, 4, 5, 6, 7, 8 groups of 4 input bits and 8 groups of 5 output bits. So there were 32 bits in, 40 bits out. the data rate of the output is therefore 5/4 the rate of the input, or 1.25 Rn. Okay? And that's because of the 5:4 ratio. Hope this helps on the 4B, 5B.